Here are the solutions for the practice factoring exam. Number 1, factor using the greatest common factor. All right, for this one, let's try to see if we can divide all these terms by the greatest common factor. In this case, they all share a common factor of 4. All right, so if we divide out a 4, we're left with 12 over 4, 3x squared. 4 over 4 is just 1x. And 20 over 4 is 5. All right, and this would be my answer because I can't factor this any further. All right, question number 2, factoring when a is equal to 1. All right, so a is equal to 1. In this case, we're going to list out all the factors of 24. So we have 6 times 4. We have 24 times 1, 8 times 3, and 12 times 2. Out of all these, the ones that add up to 10 in the middle are 6 and 4. So 6 plus 4 equals 10. All right, writing into a set of binomials, we have x times x. The last term is positive, the middle term is positive, so it's going to be a sum of the two. And the sum is going to be 6 and 4. And this is my answer. All right, number 3, factoring when a is equal to 1, but a is not equal to 1. All right, that should be a hint that there is a greatest common factor between them. So let's divide out a 2 to begin. The 2 on the outside, simplify, 2x squared, plus 10 over 2 is 5x, and 72 over 2 is minus 36. All right, so our new c is 36. So let's list out all the factors of 36. We have 36 times 1, 18 times 2, 9 times 5, 12 times 3, and 6 times 6. I believe these are all of them. Now, out of all these, 9 times 4. Out of all these, which of these add up to 5 in some way? And that's going to be 9 times 4. If we make 9 positive and make the 4 negative, we have positive 5. All right, so 2 on the outside, then a set of binomials. We multiply the x's together first. Our c term is negative, so we have a plus and a minus. And if we wanted to make a positive 5, we need to make the 9 the larger one. So x plus 9, and then x minus 4 will be our answer. All right, number 4, factoring when a is greater than 1. So first of all, we would check if there is a greatest common factor to simplify it further, but there's not in this case. So let's begin by getting all the factors of 7 and 1. All right, and then listing out all the factors of 4. So 4 and 1 and 2 and 2. Now in the middle we have subtraction, but our c is actually positive. So that means that our possible scenario in between is the sum of two negatives, so minus, minus. So numbers that add up to 11 that are both negative. All right, for the first two terms, The only option we have is 7x and x. All right, and then the other options here we have 4 and 1, and we could potentially reverse them to 1 times 4, and then 2 and 2. So really, 3 different possibilities. All right, I'm just going to begin with 4 and 1, just to check that out. All right, so multiplying the outside terms as 7x times negative 1 is negative 7x. And then the inner terms, negative 4 times x, is negative 4x. And these two add up to negative 11x, which is what I want. So I was lucky this time around. I only had to check once. So this is my answer. All right, number 5. First, check if there is the greatest common factor between all these. In this case, there is no greatest common factor. So I need to list out all the factors of A first. We have 2 times 1, and that's the only possibility. And then list out all the factors of C. We have 15 times 1 and 3 times 5. And because we can reverse the order too, we can also potentially have 1 times 15 or 5 times 3, right? So this one is looking to be like 4 possibilities because C is positive and the middle term is positive. So that means that it's going to be a sum of the two. Now right away, because it's going to be a sum of the two, I can discard 15 and 1 and 1 and 15 because they add up to something that is bigger than 13 together. All right, so let's test out what we have left. We have 2x and x in their possible first slots. We said that this was going to be a sum between the two. And 3 and 5. All right, so if I multiply the outside terms, we get 10x. And then add the middle terms, multiply, we get 3x, and that is equal to 13x. So again, I just got lucky. This is my final answer. 2x plus 3 times x plus 5. All right, number 6. Right away, I see that we have two square numbers, and we're taking the difference of them. It should be a hint here, says factor by the difference of squares. So the difference of squares says that if I have a squared minus b squared, it'll factor out to a plus b times a minus b, where these two alternate signs, all we have to do is take the square root of both of these terms. All right, the square root of 9 is 3x. The square root of 25 is 5. So we have plus 5 minus 5. And there is no middle term to check. And if you check the outside terms here, the middle term will cancel out. So this is my answer. 3x plus 5 and times 3x minus 5. All right, number 7 says factor by grouping. So we're going to check the third term. It's positive, so we can safely proceed and group the first two terms and the last two terms. All right, the greatest common denominator between the first two is just 1n, all right? And then the greatest common factor between the last two include a 3 and an m. So we can divide out the 3m for both of these. All right, in factor form, on the outside, n squared over n. Right, and on the outside, we're just left with just 1n. And then n over n will cancel out, leaving just a 2 on the outside, on the inside. All right, here we factor out a 3m. And what's left over is cancel out the 3 and the m, it's just n. And then for the second term here, we're going to divide 6 over 3, which is going to be 2, and the m's canceled, so m plus 2. Now I can piece together this by undoing one of the FOIL method steps and take the outside here and piece it together into one binomial, so n plus 3m. And then the one that they do have in common, n plus 2, is going to be at the end, like so. And this is going to be my final answer. All right, number 8 says factor using your chosen method. Well, my chosen method here is going to be the difference of squares because these are two square numbers and they're being subtracted. So I take the square root of the first term and the second term. Then the square root of 16 is 4. The square root of r squared is just r. So 4r for both of these in the slots. And now we have alternating signs, so plus and minus. And the square root of 81 is equal to 9. My final answer is 4r plus 9 times 4r minus 9. All right, and the last one, number 9. I checked if we have a greatest common factor first. We do. All these are multiples of 4. So let's divide out of 4. And if we do that, then a is equal to 1, which is easier to work with. So x squared plus 4x plus 4. All right, so now we're going to list out all the factors of c, which include 4 times 1 and 2 times 2. And the only ones that add up to 4 are 2 and 2. That is if we make 2 positive and 2 positive, they add up to 4. All right, our c term is positive, our middle term is positive, so we have x plus times x plus, and then our combinations for the c factors were 2 plus 2, so x plus 2 times x plus 2. So fully factor, you have 4 on the outside times x plus 2 times x plus 2. Or you could also write it out as 4 times x plus 2 squared. All right, either of these two answers will work.